Hi, in this video on my Raspberry Pi with the 3-bit binary counter controlled by the RPi2, I want to focus on timing, because last time it wasn't quite sure if the timing set by the control program was causing the problems. So last time I changed the 8 seconds sleep into 16 seconds sleep, but it didn't quite work out as I expected, so I have to look more into timing and the ports it goes through. So that is the focus for this video, and let's first start with running it again. So I'm starting the counter, and run the control program. And of course, one thing that should work is the speed of the binary controller, because when I changed it some time ago, the counter considerably slowed down, and I haven't managed to fix that. And I wonder if that is due to this timing or due to something else. I haven't figured that out yet. And I don't know if you can you probably can't see it from here. Let me turn. You can very vaguely see let's burn. I have to find a solution for that as well, so you can see the LEDs, because from my side I can see it, but this camera is pointed in the wrong way, I think. Perhaps I should put this in another way. Let's see if that works out. I think this is a better solution. So anyway, although you will see it now in the backward, with this being the 1 and or the first bit, and this being the 3rd bit. But anyway, you will see it better like this. What hasn't changed yet is the speed up of the bits. And what also hasn't changed yet is the time between the numbers. And that is something I have to focus on as well, but let's first see if it runs anyway. Also, now we have a nice view on this one. Reverse should of course mean that you go from 6 back to 5, back to 4, back to 3. And my idea is that 16 seconds would be enough for a count back or count up. However, if the general timing between the various numbers is different, that may also mean that I have to change this number to an even higher counter, to a higher sleep or delay or whatever you can call it. So let's do a test with that. Quit this and see if that quits fast enough. It should be nice if it does. Or does it continue counting? That's a nice question. Ah, now it stops, although the other program on the RPi1, the counter is actually running. So I think this is freezing up right now. So let's change this 16 into 20. And that goes of course for each sleeping time. Then compile. And run again. And you see immediately that the counter does have an influence, because as soon as I start the counter control, you'll see that from 6 it went to from 3 it went to 4. I should not point at the thing, but point here in the cam. So it's 4 now. But this should not mean that the time between the numbers is 20 seconds. It is the time between counting up. So it counts up for 20 seconds and then counts downwards or counts back for 20 seconds. Not the timing between this. This should go like seconds, and that is certainly not the case. So let's check on the other code, the actual counter. See, and now after considerable time it goes to 6. Number 6, as you can see here. So that is not quite alright. Time to hold the control. Let's wait for it to end. And let's press Ctrl C here as well. And then the LED should go out if that one is stopped completely. Okay, this one has stopped. It all takes too much time, and my guess is that somewhere in this code, the counter code, has something gone wrong along the way. And as you can see, from 4 it has gone to 5, which means that the counter still runs. Which is not the idea. And I hope I don't have to kill the program manually. And I can do that, of course, since this is all on Linux, that I can use the kill command, but I hope I don't have to do that. But it's taking an awful long time. So let's open a new window. Let's find the process number. It is in here, 2679, or more accurately 2678. It's running as root, so I have to do sudo kill 2678, and there it goes. So I will check for some code and then see what happens. So in order to know how much time elapses between numbers, I've found a simple algorithm on the net for time. And next I call it algorithm after each number, so it displays the current time. So let's start the algorithm. Control algorithm has continued to work, and here you see the first result, 13:07, as is the current time, and 49 seconds. Of course, I could also have done all time minus current time is the elapsed time, but I figured this is about as easy. And then I'm curious what the next timestamp will be, and in what input state. Because right now it's input state 0 here, and here we get really 1 minute after the first, and it goes to input state 1. And this is a difference of 20 seconds in input state 0. Now that was in input state 1. and then it's waiting for the next timestamp, and that is obviously going to take some time, but already the difference between 1 minute and 20 seconds, and here again 1 whole minute, so that's obviously a counter that is not quite worth waiting for. And while we wait, see, and this again 20 seconds, so let's wait for the others. If this becomes 11:29, it is really time to think of a pattern between the control program and this, although the control program is 20 seconds, which is like this difference, input state 0 and 1, which is 20 seconds, but while the other one is 1 second, 1 minute, is not a question. And indeed this is 1 minute. So now I know there's this is influenced, this is clearly influenced by the control program, but then why? So this is input state 1, input state 0, 1 and 0 again. So this shows that that there isn't even enough time to count within an input state. So I have to do something about the timing. So this is quite an interesting thing, and here you can see again 1 minute and here 20 seconds. So this is all about timing, and the question is, how much time does it take between one input state to, or in one input state, to count between the numbers? That is something I have to figure out. But as you can see, time telling is a nice way to figure this out without a stopwatch. And this also tells why the counter isn't working as I expected it to be. Perhaps I need to decrease this counter back to 8 or even back to 4 as it was originally, and then see what happens. Actually, let's do that. And go to line 41. And compiling again. Starting. And here obviously it's now 4 seconds. So that is a dramatic increase. 44 seconds is 12 seconds. but it's still input state 1, input state 0, input state 1, input state 0. Obviously much faster now, but it's still 0, 1, 0. So why does it, and here 12 seconds, 4 seconds. So obviously that is a change in pace, but why does it not but why is it so quickly changing between input states? That's a big question, and that's going to take some research, some looking into the code. Right now I think this is quite a nice result, and for now thank you for watching, and certainly to be continued.